Welcome to Winston Food Service. My name is Donna Sharper. I'm the Director of Sales. In our FCSI presentation today, we will be covering precision temperature cooking and holding via controlled vapor technology, which we will refer to CVT. For some of you, this will be a refresher course. For others, this will be your first exposure to controlled vapor technology. We hope you learn a lot, we hope you enjoyed the presentation, and we look forward to answering any of your questions later. Our agenda today will be the history of Winston Industries, an introduction to CVT, what is CVT and the benefits of CVT, which will include food yields, repeatability, versatility, precision, and which clients are best suited for CVT and why. In addition, we'll be doing a comparison of CVT to combi ovens, sous vide cooking, convection ovens, and also talking about how consultants can specify CVT in a variety of ways. At the end of our presentation, we will then present Winston's CVT brand, which we call C-Vap, and the variety of model configurations it comes in.
Welcome to the Winston Food Service Test Kitchen. I'm Barry Yates, Global Accounts Manager for Winston Industries, and I've been with Winston for 30 years this June. And we're here to talk about the brief history of Winston Industries. Our company was founded by Winston Shelton, who was a career engineer with General Electric for over 20 years. He grew up on a farm in Clay County, West Virginia, where he then went on to join the Army. While Winston was in the Army, he actually got selected as a part of a special training program and was sent to Princeton to train. He was trying to decide if he was going to stay in the Army or what he was going to do next, and actually he got recruited by General Electric. While working at GE, Winston actually spent a lot of his time working on the development of what we would say is the modern day washing machine. Many of the patents that are attached to GE's washing machines have Winston Shelton's name on them. So that led Winston to actually develop a prototyping business with his brother Naaman, where the first projects they were working on this is in 1965, 66, they were working on zero-turn lawnmowers. While working on the zero-turn lawnmower at his prototype shop, one day Winston had an interesting visitor pop in, and that happened to be Colonel Harlan Sanders, of all people. At that time, the Colonel was actually franchising his business, and most of the people that were frying his chicken were using pressure pots on top of ranges. And you can imagine how complicated of a process that could be. The Colonel was having problems with product consistency coming out of multiple pressure pots and was looking for a way to automate his frying process. As Winston studied the actual process that the Colonel had developed, he realized that the problem that he was facing was the fall off from the chicken breading being in the pot and burning up, and so they'd have to dump the pot after one cook. Otherwise, the crackling would burn and the chicken would not be consistent. As he thought more and more about it, we ultimately created what was a self-filtering collectromatic pressure fryer, which went on to become the #1 pressure fryer in KFC system. The Colonel actually worked with Winston and went around the globe selling collectromatic fryers. He was our #1 salesperson. As Winston and Colonel traveled the world selling pressure cookers, Winston heard the Colonel mention many times that he wasn't happy with the quality of the chicken after it had been held, and at that time they were using just a standard hot box. And that got Winston to thinking, how can we hold fried chicken hot? He wanted to make the Colonel happy because he'd been such a friend and a mentor, and so began the work of developing CVT. The Colonel actually never got to see Winston's C-Vap holding cabinet. He actually passed away before Winston finalized that project. He thought that KFC would adopt it, but actually they weren't very interested in holding fried chicken at that time. But it was a very dynamic period in the food service history because the advent of the drive-through windows had the industry booming. And it wasn't long before our first major customer was McDonald's, and they were using CVT cabinets to hold hot sausage and biscuit sandwiches. Then we went to Wendy's, Burger King. So the growth of Winston food service actually followed the growth of quick service restaurants. And we followed them to China, to Australia, to South Africa. We've actually been a global supplier for well over 40 years. Today, we're still a privately held independent company and the proud owners of 2 technologies that span the globe. As I began my work at Winston as an R&D chef and working with Winston on hot food holding, it soon became apparent to both of us that CVT not only applied to hot food holding, but it applied to cooking as well. Up until that point, as a classically trained chef, I was taught how to cook with the oven, cook in a saute pan, cook on a grill, on a flat top, and the method for controlling the temperature in all of my cooking processes was based on the skill sets that were taught to me by other chefs. Thinking that you could control food temperature in a cooking process with water vapor was kind of strange. I'd been taught to use sous vide. That was a precise method for cooking food with water. I'd been taught how to steam fish. I'd been taught how to steam rice. I'd been taught how to poach chicken breasts. So as I started to relay that thought process, it became apparent to me that water vapor in conjunction with air is what truly gave me precise control over the cooking process. So we'll get into that a little bit later. Right now, how about we go to our little whiteboard video on C-Vap 101.
Cooking food in a commercial kitchen can be a lot like a science experiment. Too much dry heat and the food gets torched. Too much moisture and you've got mush. That's why at Winston Food Service, we developed C-Vap technology. C-Vap, which stands for Controlled Vapor, makes it possible to easily produce food at the perfect temperature and texture. What's the secret sauce for this precision? Science. Let's start with the basics. Food is mostly water, yet no other cooking or holding technology controls water content the way C-Vap does. How does it work? Simple. C-Vap creates a vapor cloud that has a very precise temperature. The food, which is again mostly water, reaches the same temperature as the vapor cloud and never overcooks. Think sous vide. What about texture? Instead of preventing evaporation, C-Vap's convected heat controls it. It keeps moist foods moist or crisp foods crisp. To learn more about the precision of C-Vap technology and how it vaporizes the competition, request a demo.
As I was saying earlier, when I first started working with CVT, a big part of the problem was my reference from my training to just dry bulb cooking. And I wasn't certain how to translate my trained skills to C-Vap. As I talked to Winston more and more about the translation problem, we came up with a good starting method for how to get at least guidelines for starting cooking, and then after a while it's just like regular cooking. You get your preferred settings for whatever process you're doing. And the basic guidelines that we started with were whatever endpoint temperature you wanted to have for the product you were cooking, that is where you set your evaporator or wet bulb. And depending on the type of process, if you were, say, like steaming, you would want next to no air, so it would be 0 degrees above, so it'd be 210, 210. That would give you an exact steaming environment that you're used to. Now, this is pressureless steaming. We don't have, our ovens aren't pressurized. Proofing, 90 on the wet bulb or evaporator and 0 on the air, so 90 to 100. That gives you a perfect proof. Crisp cooking, you would set anywhere from 140 to 180, or even up as high as 210, and 120 to 140 above that, and that gives you about anywhere from 300 to 350 on the air, and that is ideal for cooking like roasted chicken. If you want to go to baking, you back the wet bulb down a little bit, but elevate the air, and that gives you a perfect environment for breads, cupcakes, sheet cakes, and actually this is the best cycle for custards and cheesecakes. But that is how we have taught people to translate their classic cooking cycles into C-Vap. Now that you've learned a little bit about CVT, both holding and cooking, it's time for us to talk about the advantages of CVT. The first advantage of CVT that comes to my mind is high yield cooking, specifically like on large roast. We're going to bring in our corporate research chef, Miss Samantha Brown, and she will show you how high yield can give you a quality prime rib.
Thank you, Barry. My name is Samantha Brown, and I'm the corporate research chef here at Winston, and we're going to look at a prime rib that I prepared for us last night in a CHV oven. So the first thing that it is, obviously, I took it out of the package, I trimmed it up, I took a weight on it, and that weight was 14.02 pounds. And the idea is to get a really as much yield as possible out of this protein, because it is expensive, and whole meats are very expensive, and you get one shot. So I think that this is a very ideal for this type of cut, and it can be translated to any kind of large cut protein, whether it's a top round or a turkey, you know, you name it. So I'm going to open up our C-Vap. I'm going to weigh it, and I'm going to calculate our cook yield, and then we're going to cut into it, and I'm going to show you end-to-end doneness and how that looks. So from here, I'm going to put it on the scale. I've got a pan on top of the scale. It's tared out to 0, and I'm just going to gingerly lift it. So our weight is 13 pounds, 18.9 ounces. So we need to convert 8.9 to a decimal point. Which is 56. Oh, 13.56 divided by 14.02 times 100, because this is a yield percent. 96.7% cook yield. How did I set up the program? The program that we used, it's pretty standard. It's what we would tell any customer that wants to do prime rib. 130 vapor, 130 degrees Fahrenheit on the vapor, 180 degrees on the air. That's a 50-degree differential, so it causes some evaporation and drying on the outside of the prime rib. The convection was on, high yield was off. There's another option that we can get into later. And then it went in, so I didn't stay here all night and watch the prime rib, so it went into an automatic hold, which was for an infinite amount of time. And we kept that at about 130 on 130 Fahrenheit on the vapor, 132 on the air. So 2 degrees differential there. We want to keep that temperature close to our end point temperature, which is a nice rosy rare, with just a little bit of evaporation. We don't want a whole lot of evaporation to where we're cooking even further, but we want to keep it dry on the outside. From here, I am going to place it on the cutting board, and we're going to do a lateral cut, which is from end to end. This beautiful prime rib, end to end would be this way. You're bisecting it would be this way, just a natural half cut, but we're going to show you from one end to the other end. So what do you see with traditional prime ribs? You might see some what they call a bullseye, which is a really dark red center. And you're going to have some medium well end pieces. You're not going to have that with CVT or C-Vap. You're going to have medium rare, end to end, top to bottom. I mentioned bullseye before while I was making this lateral cut. So what does a bullseye look like? Obviously we don't see that here. We see nice rosy red from end to end, top to bottom. But a bullseye is going to have, like, the geometrical center of the roast is going to be really red with varying degrees of pink on the outside to gray. So it's literally like a bullseye. Why does a bullseye happen in a roast like this? It happens because the temperature of your convection oven or whatever traditional method that you're using is much higher than what you need it to be for a roast. Whereas in CVT, you're using 2 different methods of cooking, using wet bulb and dry bulb. The wet bulb drives end point temperature, and the dry bulb drives evaporation or texture on the outside of the roast. You who have cooked prime rib or steaks or large muscle meats before, not using CVT, you will notice around my workstation there's not a lot of purge or weeping or a liquid seeping from the roast because it's in the roast itself. It has already had time to acclimate. Another reason why you will see a lot of moisture around the area of someone who's using a traditional cook method for a roast, and you see the bullseye, is you haven't given the proper amount of resting either. So you will always see that bullseye, but that muscle will relax a bit, and some of the juices that have been pushed towards the inside of the roast will kind of equilibrate to the outside. And then if you don't do that rest, you lose it all. You lose it all before it gets to the customer.
Now that we've covered that, let's move on to another benefit of CVT equipment, which is repeatability. One of the things that is most valued in any food service establishment is to create a method for quality and keep that quality burger after burger, steak after steak, roast after roast. With CVT equipment, we can give you precise temperature control and texture control, and it doesn't matter if it's 1 burger or 20. It doesn't matter if it's 1 piece of fish or 100. I think one of the best demonstrations of that is for hamburgers. Hamburgers are a hot menu item today, and cooking a burger from raw to the perfect endpoint takes a lot of skill, even if you're a trained chef like myself or Sam. Cooking 20 burgers to the right endpoint takes even more skill and is nearly impossible. I don't care how good of a cook you are. With CVT, we have a process that we call CVT staging, and we take raw burgers that can be anywhere from 3 ounces to 8-ounce patties. We set the endpoint on the evaporator to the temperature that we like. In this case, I recommend about 145, but you can have it at 135 if you'd like. You can have it at 155 if you like. On the water vapor, then we set the air temperature at just a little bit over that. I normally recommend like 2 degrees above it just to get the moisture level off of the patty, so that whenever you finish it, whether it's on a grill or charbroiler or a flat top, that you get a good sear. One of the great things about CVT staging, and this doesn't really just pertain to burgers, but in this case I'll relate it to burgers. It doesn't matter if you're dealing with 2-ounce sliders, a 1/4 pound patty, or a 1/2 pound patty. You can put all of those items into a CVT oven at the same time, and while the 1/2 pound patty will take approximately 60 minutes to get to endpoint, the 2-ounce slider will get there in about 25 minutes. But even though it's in there with the 1/2 pound patty, the 2-ounce slider will not be overcooked during the process. It will stay at the exact 145. A CVT staged burger will get to the texture that you want, whether it's on a grill or on a flat top, in 1.5 minutes. So you've just reduced your ticket times 100-fold. The joy of this technique is that it's fully repeatable, and it doesn't matter who the cook is. Once you've trained the process, the oven does the precision work, and somebody just needs to know to have the patty on the grill charbroiler for 1.5 minutes. Application for CVT ovens that we see particularly in large volume venues is the exact reverse of CVT staging. At those venues, normally they don't have enough labor to finish a la minute 100 burgers. So instead, they are pre-searing and then putting into the CVT oven and letting them get to the endpoint temperature. So then all they have to do is make a sandwich at the end of the line. Another huge advantage of CVT ovens are their versatility. In the evening, you can do a prime rib, just as Sam just showed us. You come in the morning and you can proof your bread. Once the bread's finished proofing, you can change the oven to a holding cabinet or staging cabinet for your burgers at lunch. And then at dinner, you can hold your barbecue chicken breast or cook a beef tenderloin. So with one piece of equipment, you could do all those processes within the framework of a day. Another area where CVT ovens are flexible is where they can be installed. With all the talk about ghost kitchens and remote locations, and even schools having to put cafeterias in rooms that never had a kitchen, CVT ovens are hoodless, and not only do they give you the menu versatility that is needed in an organization like a school, but they also give you the versatility of where you put the kitchen, so you can have food service operations in places you never dreamed of before. A final but very important benefit of CVT cooking is the precision with which you can cook. It gives you the ability to do very delicate items like eggs, shrimp, seafood, even steaks, to the precision of sous vide without the need for bags.
My name is Gary Wyckoff. I'm the regional sales manager. I've been with Winston Food Service for over 10 years now. So when you're working with CVT, it brings another dynamic to the kitchen. It can be the traditional cook and hold oven that's in the corner. You can put our cook and holds adjacent to the cook line. I've seen it designed in the chef's counters. I've seen it put into custom cooking suites. And even when I work with our clients that may not be familiar with controlled vapor technology, once we do the demonstration, we get it in place. I've had some of my end users claim they're going to rethink their entire menu. Keep in mind, we do cook and holds, holding cabinets, holding drawers, retherm ovens, and the basis is around controlled vapor technology where we control food temperature and texture separately. It's just a dynamic for the end user. Our extended holding times are some of the best out there in the business. I love when you can hold those proteins for 6, 8, 10 hours and still serve a marvelous product. And it's just been a game changer. For those unique spots being our holding drawers, our HBB series, same technology, controlling food temperature and texture. Understanding that 5 degrees is a big deal in our business. So whether I'm holding something as simple as a muffin or that coveted baked potato, or something as simple as you think as a potato chip that's still, or a tortilla chip that has 11% water content, to hold them hot and crisp, we can do it better than anybody. Working with CVT technology, I've got a lot of my end users over the years as blast chillers has been introduced, cooking large portions in bulk, large proteins, blast chilling them down within the food safe guidelines, and then within the next day they're able to retherm within around an hour's time, hold all the way through lunch, retherm once again for the dinner period, and really reduce ticket times once again on those large protein type items. And as your to-go orders are increased, able to hold those to-go orders as needed. Controlled vapor technology is great on the retherm aspect because, again, we do understand that food is water, and so we can retherm at a gentler temperature and bring it back up to the food safe temperature without drying out your food. With using controlled vapor technology, we are also EPA 202 certified. We have all the documents to support for certified ventless. I will say local jurisdiction will apply, but we've had many successful installations where we are cooking outside the hood envelope. When working with controlled vapor technology, I see it in every segment, whether it's a daycare, a school, college, university, fine dining, fast casual, any cuisine. We are seeing controlled vapor technology put in the back of the house, producing full food in bulk. We are seeing it in the front of the house, holding in a simple drawer or a full-size holding cabinet on their to-go orders. We are seeing it in their hot and ready pizza programs. When working with controlled vapor technology, I've had the joy to work with a lot of assisted living centers where it's really been a game changer in their kitchen from producing food for their residents. They understand how many breakfast, lunch, and dinners they're creating. That has really helped. The only time that really does change is when it's guest day or family day, where that may change, but their menu stays reasonably consistent. So when we actually help them save on labor as well, because they can produce food when it's required and release the labor, and they know that they're holding that product perfectly, so when it comes time to serve, the food is ready to be served. Also working with controlled vapor technology, my end users have pointed out how it complements almost everything in the kitchen, whether C-Vap is standing alone, whether it's a cook and hold in the corner finishing product, where it's holding perfectly fried products that's come out of the fryer, whether it's our staging method where we par cook it and finish it on a grill or a broiler, and how it complements in so many areas of the kitchen that has really helped with reduce ticket times by up to 2/3. So in some points, literally, I can finish a steak faster than the server can create a salad.
I'm Chef Paul Wahlberg from Wahlburgers, and I'm down here in Louisville, Kentucky, because we're down here with Winston Industries, and we're talking about the C-Vap equipment. And I have to tell you, it's made such a huge difference in the job that I do, because we cook burgers, but the precision that the equipment brings, the efficiencies, the time, everything, reduction of labor, all of these different pieces come into effect, and you don't really understand it until you actually experience it.
My name is Scott Rodriguez, Senior Vice President of Culinary and Kitchen Innovation for BJ's Restaurants. We are based in Huntington Beach, California. We discovered it first at the National Restaurant Show. We were looking for a cooking platform to help us with the launch of a slow roasted menu we had been working on. The solution it provided for us was a consistent cooking platform, really is how we use it, for our proteins that's high yield and that we can use throughout the day, and ease of use for our team members. It's very easy to use, and the product is very, very consistent coming out of it.
Hello, I'm Melissa Rose. I'm the Executive Sous Chef here at the Hyatt Regency McCormick Place. I've been with Hyatt now for about 10 years. At this property, because we have such a sort of unique and diverse clientele, we're always looking for new and different ways to sort of stay in front and be ahead of the curveball as far as how we can be faster and better and stronger all the time. The major change for us has been using the C-Vap technology as a staging box, because what we actually do for service is we stage a lot of our food in the box. So we'll hold burgers, for example, at 135 degrees. And from there, you can take a perfectly rare burger out of that box, and I can hit a medium rare burger in under 2 minutes. And I joke around with people, it actually takes longer to toast the bun sometimes than it does to finish the burger, because you just get a hard sear on both sides, and you have a perfectly medium rare burger.
Hello, my name is Linda Bedell, and I'm the Northeast Regional Manager for Winston Food Service. Though I'm relatively new to Winston, I'm a 20-year veteran of the food service industry, and within that time I've worn many hats. Along the way, I've worked with both CVT technology and combi oven technology. And what I'd like to do today is talk a little bit about both together, both as how CVT can work as an alternate for combi oven technology, as well as how it can work in conjunction with as a complement to combi oven technology. Over the last 30 years or so, combi oven technology has really soared in popularity all over the world, and with good reason. Combi ovens are a workhorse piece of equipment. They're able to act as a standalone convection oven, a standalone steamer. You're able to combine the moist heat and the dry heat in whatever percentage of humidity you're looking for. You can use them for high temperature grilled and fried like items. You can do overnight cooking in them, baking in them, and actually use it as a holding cabinet if you need to. One of the best ways to make sure you are using your combi oven to its fullest potential is to have complementary pieces of equipment with it. And there is no better partner to a combi oven than a CVT oven. There are many ways that you can use combi ovens and CVT ovens in conjunction with each other. For example, as Barry will talk about later on, you can use a CVT oven for bagless sous vide because you're able to dial in the exact vapor temperature and air temperature, or in sous vide, it's really just going to be the vapor temperature, to get the exact temperature you're looking for. You can then hold that sous vide item until you're ready to serve, and you can finish it in a combi oven or any other way you choose. One of the main differences between CVTs and combi ovens is what combi ovens have in speed, CVTs have in precision. So you have to figure out where to use your resources. So a combi oven can really benefit almost any establishment. CVT can act as the perfect connector to any piece of equipment in the kitchen, including a combi oven. On the flip side, if you're looking to do fast, high temperature items in the combi, you can cook them in the combi ahead of time and then hold them in its perfect environment in the CVT oven so that when you're ready to serve them, they're ready to go. With combi ovens being as versatile and powerful as they are, it does come with a price tag, and I've never met a kitchen operator who did not have budgetary concerns. One way to use the CVT oven, again, is in conjunction with the combi oven as opposed to getting 2 or 3 combi ovens. Just because a combi oven can be used as a cook and hold doesn't mean that it's the most efficient way to use it. So just because a combi oven can hold, it's not holding with the precision of a CVT oven. So the CVT oven is going to give you extended hold times where the combi oven will start to dry food out. I once saw a combi oven and a CVT oven side by side, both with prime rib. Even though they were both cooked at the same parameters, the prime rib out of the CVT was much moister and juicier for a lot longer, and thus it was servable a lot longer. It also had a higher yield, so you were able to use more of that protein than you were if it was cooked in the combi oven. For fried items and crispier items as well, you can hold in the CVT much better than really any other piece of equipment, not just a combi oven. Again, that's because we have that ability to dial in the precise environment for whatever food it is that you're trying to hold. Whereas a combi oven can give you a percentage of humidity, it's not giving you that precise environment that we can. Another way that it's helpful to work with a combi and a CVT oven together is that the CVT oven is hoodless and ventless. So that means you have more room under the hood for your other pieces of equipment, including combi ovens, and your CVT oven can be outside the hood and it's mobile. All you need is the power and access to water, and your CVT oven is operational. As I stated before, just because you can use a combi oven as a holding cabinet doesn't mean that's the best use of this type of investment. It's better to use the combi oven for some of the higher temp items, the items you need to be done quicker, and use the CVT oven for the slower, more precise items and for holding. That way you're using the combi oven to its best potential and the CVT oven to pick up the slack. So we've established that combi ovens are extremely versatile and powerful pieces of equipment, but that does not come without a cost. The initial investment for a combi oven alone is between $15,000 and $40,000. Then you have to add in all of the infrastructure costs along with it. Combi ovens do have to go under a hood, so you have to budget for hood space. You do need a drain and a water line connected to it. You will need electrical power and potentially a gas connection if you're running on natural or propane. To be able to use the combi oven in the way that it was intended to use, there are accessories to purchase, as well as cleaning tablets or chemicals. The maintenance needed on a combi oven is pretty excessive. You need to descale it, you need to have routine checks, and if something is down, you're gonna have time out for your servicer to make the repairs. A lot of times, if you choose not to use the manufacturer's chemicals or tablets, it'll void your warranty. And if you're not cleaning and maintaining the combi oven properly, you will shorten the life of the combi, which will just lead to a larger investment in the future. Another harsh reality of the combi ovens is that they are so sophisticated that they are underused. You have the ability to do so many things at one time that it's almost overwhelming. I have walked into kitchens with combis and I've seen them either at 350 degrees straight convection or 212 degrees as a steamer, because that is the path of least resistance and that's where the cooks are comfortable. You need a lot of training to really be able to squeeze all of the benefits out of using a combi oven properly. While cooking with a combination of moist and dry air yields fantastic results, unless the operator really knows what they're doing and programs it properly, they're really paying for a lot of functions that they're not using or not using properly. Again, just because a combi oven can do something doesn't mean that it's going to actually be used in that manner by the operator. So you're paying for a lot of functions that really may be left on the table. Now, for those with serious budgetary or space constraints where one combi oven may not be an option, let alone several, you can use a CVT oven as an alternate for all but the ultra-high heat items, as CVT ovens top out at 350 degrees. With the range of 0 to 210 degrees on vapor temperature and 0 to 350 degrees on air temperature, you can find the perfect environment for proofing, steaming, baking, braising, and overnight roasting all in one footprint. Because CVT ovens are hoodless, unless a particular municipality says otherwise, and only require a connection to power to work, they are mobile and thus flexible in almost any design. Front of the house, back of the house, ghost kitchens, or food trucks. The possibilities are limitless. In terms of ease of use, you cannot beat the CVT oven. You set your programs, they're numbered, you press the button, and you walk away. Most of the times, you'll be able to set it for an infinite hold, so the food will be ready when you need it to be. If you're looking at a full-size 10-pan combi oven, you're going to be looking at paying around $1,850 per sheet pan. Conversely, on a full-sized 14-pan retherm oven, you are going to be paying around $678 per pan, which is more bang for your buck due to the additional pan space and costs considered. So I'm not saying to not use combi ovens, but really you can probably get away with using maybe one combi oven and several or stacked CVT ovens to lighten the load of the combi and to shorten your space under the hood. In an ideal world, combi ovens will always be paired with CVT ovens to handle the overflow and to provide longer hold times in better environments. If a client doesn't have the budget or hood space for a combi oven, a CVT oven can replace a combi for all but the high temperature items. Whatever your menu or design, we are here to ensure that you choose the right piece for your operation. Now I'm going to throw it to Barry Yates to discuss how CVT stacks up against traditional sous vide.
Now we're going to talk about one of the most precise methods of cooking, but also a very popular method of cooking, sous vide. Sous vide cooking is a method that was developed by the French to both preserve and to enhance flavors of different menu items. The term sous vide itself means under vacuum, and the process involves plastic bags, whatever product that you're wanting to cook. It could be lamb chops, it could be chicken breasts, steaks, and you place the product. In this case, I have some chicken breasts in a vacuum sealer, and the vacuum pulls a seal on the package and then seals it. Thus, it eliminates any oxygen around the chicken breast, and if you did nothing else, that would extend the shelf life of the chicken breast by quite a bit. Another advantage of sous vide cooking is that it can enhance the flavor by vacuum marinating the product. So you could put butter, soy, garlic, vinegar, any number of aromatics, and actually drive the flavor into the chicken breast or the steak or the lamb chop. Once it has been vacuum sealed, traditionally you'd have an immersion circulator, which has the ability to heat water to a precise temperature, and you cook the chicken breast in this case, but also could be steaks, lamb, seafood, whatever, to the temperature that you selected. For chicken breasts, we recommend 145 degrees. And that takes about 45 minutes with the immersion circulator. And the chicken breast is precisely at 145. Traditionally, then you would take that out, finish it in a saute pan with the beurre blanc, or throw it on the grill, or throw it on a flat top, and you would have quick service time and perfectly cooked chicken breasts. While sous vide works best for cooking meats, you can do asparagus, you can do fruit, you can do any method, any type of food that you want that you're looking for a very precise temperature. The primary benefit and the reason I like the sous vide method is precision temperature cooking. The thermodynamics of cooking in a water bath that's controlled to a specific temperature eliminates the ability for the food to be overcooked. So if you know what temperature you want your product to be at, you set the water bath to that temperature, and in a given amount of time your product will be at that temperature and stay there indefinitely. Concentration of flavors and juiciness is another benefit of sous vide cooking. As I was sharing earlier, being able to vacuum marinate products will drive flavor into it. The ability to just set it and forget it, because food can't be overcooked. Sous vide doesn't require constant attention, and you have your product ready for when you're ready to finish it for the customer. Finally, the location, tabletop and typically at the back of the house. It doesn't take up a lot of space on the cook lines. With all the benefits of sous vide cooking, it also has some disadvantages. Sous vide is by its nature a slow process. It's not high energy, driving temperature fast. That can benefit the food, but at the same time, you're limited by space. How many immersion circulators can you put in the kitchen? How many bags of chicken will one immersion circulator hold? All of those are disadvantages depending on the type of volume you're trying to produce with the sous vide system. Expense can also be a consideration, especially in a high volume environment. You would need a lot of immersion circulators. Another is the need for makeup airspace. With multiple immersion circulators, you're creating a lot of vapor in the environment. Commercial immersion circulators cost around $1,500, and another disadvantage I see in a lot of kitchens is the actual precision of the cooking isn't what you normally expect, because this pot's not insulated. It's losing energy to the atmosphere, and if you fill the immersion circulator, you actually are limited by the power provided for the circulator itself. It may not be able to keep up with the load that you put into your pot. Another cost that is attached to sous vide method that a lot of people don't think about is the bags and then the labor that it takes to fill the bags. If you are highly dependent on a sous vide process, that could be a costly process. Adopting the sous vide cooking method can be too complex for certain operations, and place on top of that the requirement of many local health departments to have a HACCP for sous vide process. That could be a disadvantage to an organization depending on their complexity. Let's take a moment to review our CVT sous vide re-engineered video.
Improving the speed of service and consistency without sacrificing food quality is the holy grail of food service, but it's not always easy to achieve. One of the most effective methods in reaching this goal has been sous vide cooking. The process of cooking foods wrapped in vacuum-sealed plastic bags by submerging them in water that stays at the desired endpoint temperature of the food. The food reaches the perfect temperature over time and then stays there for as long as you need without drying out, losing nutrients or flavor, or overcooking. When an order comes in, it only takes a few minutes to season, sear, and serve. Easily 4 to 6 times as fast as a traditional cook-to-order process, and harder for a cook to mess it up. Improving the speed of service and consistency without sacrificing food quality. Sous vide works great for smaller restaurants, but is far more challenging for chains, hotels, or institutional food service. If you're serving a lot of customers at once, you probably don't have the room to fit all those immersion cookers that you'd need. Even if you have the room, you'll turn your kitchen into a sauna. C-Vap staging is the solution to this problem. The Winston C-Vap oven surrounds the food with a gentle vapor cloud and heats it up to your desired specific temperature. It has all the same benefits to a traditional sous vide setup, with the capability of doing so much more. Along with the increased volume, C-Vap staging also allows you to go bagless if you want. Why bagless? Well, those bags certainly aren't cheap. Opening them and disposing of them can be a pain and create a mess at your workstation. Less plastic means being more green. And why add extra steps of vacuum sealing? But if marinating is your thing, C-Vap's gentle heat can handle the bag. Not only does that take time, it also means that you have to have a far more complicated HACCP plan. Nobody likes an angry health inspector. C-Vap staging has re-engineered sous vide to meet the needs of every type of restaurant. If you're looking for the quality and speed of sous vide, but don't want to deal with the challenges that come with it, this is the ultimate solution for you.
We're going to look at 2 different sous vide techniques. One that is traditional from a immersion circulator, and the other one is a CVT sous vide. So first I'm going to get the traditional one out carefully. Just set it to the side, and you either use scissors or a knife like I'm going to use. These are nicely sous vide chicken breast. And now we're going to pull from CVT oven. So we have 2 different types of chicken breast, not really types of chicken breast, but we've got 2 applications. We've got traditional bagged chicken breasts, and then we have a bagless chicken breast. And then let's talk a little bit about the program that we used. We wanted to, again, we're replicating a sous vide style cook, which requires 100% water or 100% relative humidity, which is what CVT can give you. So the program that we used was 145 degrees on the wet bulb and 145 degrees on the dry bulb. That's 100% relative humidity, and we are simulating sous vide style. So again, you can, the benefit here is to be able to either use your current program, which is a bagged sous vide type, or a bagless, with comparable precision in cooking, and you can increase your volume. Like Barry said before, you can only put so many bags in a sous vide water bath with the amount of volume, where you have the option of putting multiple bags or multiple pieces of product on a hotel pan, on, you know, depending on the size of the cabinet, a whole lot more. You have the ability to increase your volume tenfold with CVT. So here we have a bagless CVT chicken breast versus a bagged traditional sous vide immersion style. The overall goal for CVT sous vide style cooking is to be as comparable or better than the immersion circulator, with the same precision, greater volume. And you also have the option to go bagless. So we know that we can do bagless sous vide style Let's take a look at a apples to apples, bag to bag, CVT versus traditional sous vide.
So as you can see, CVT ovens are a good option for anybody that's wanting to do sous vide cooking. But they're especially good if you're a high volume operation and you want the benefits of sous vide, but you want to be able to produce a lot of product, reduce labor with reduced costs, and in a small footprint.
Hi, I'm Spencer Cole with Winston Food Service. I'm one of the global account managers and I cover domestic chain accounts, the South Pacific, and Europe. In the next couple minutes, I want to review convection and conventional ovens and how they compare to controlled vapor technology, which you just learned about from my colleague Barry Yates. As you may know, two of the more common and familiar ovens in restaurant kitchens are the conventional and convection oven, which are very similar, but there are subtle differences that we would like to point out. A conventional oven has two heating elements that heat air inside the oven to cook food. The heating element at the bottom of the oven is mostly used for cooking and baking, while the heating element at the top is mostly used for broiling. As we all know, a conventional oven heats dry air to whatever temperature you set the oven to, and that hot air passively circulates around the cavity, cooking the food. Its big brother, the convection oven, has two main differences: a fan and an exhaust system. The fan helps circulate hot air around the cavity of the oven, reducing hot and cold spots, allowing the food to cook more evenly throughout the oven. In addition to cooking more evenly, the circulation of that air allows the oven to cook food faster than in a conventional oven. Convection ovens can be utilized at lower temperatures compared to conventional ovens, which helps to avoid overcooking. The pros of a convection oven over a conventional oven. Air circulation helps minimize hot or cold spots in the oven, so food cooks more evenly. Compared to conventional ovens, a convection oven cooks much faster. Airflow makes convection fans more efficient at heat transfer, so food can often be cooked at lower temperatures. For example, a food that typically requires 350 degrees Fahrenheit in a conventional oven may only require 300 degrees Fahrenheit in a convection oven. Because the heat is not directly radiant, multiple items may be baked without temperature drop. The oven treats the entire oven load of product as a single item and everything cooks evenly. Some less desirable aspects of the convection oven. Because convection ovens operate so differently from conventional ovens, recipes must be adjusted in both time and temperature. Otherwise, foods will overcook or burn. Convection ovens have many more moving parts compared to the conventional oven, each of which can fail. Repairs tend to be expensive. While you can cook several dishes at once in a convection oven, if you overcrowd the oven or block the fan, your efficiency will drop, which can lengthen the cook time or undercook the product. As you have probably figured out by now, the difference between conventional and convection ovens compared to the CVT ovens is controlled vapor. Chef Barry and Chef Sam did a great job illustrating the benefits of CVT and the importance of vapor in cooking. Since food is mostly made up of water, the CVT oven has all the pros of the convection oven, with the added benefit of controlling vapor temperature, which you just learned directly controls the temperature of your food.
Hi, I'm Corey Ainsworth, Southeastern Regional Manager for Winston Food Service. Earlier in the presentation, Chef Barry Yates walked you through the history of Winston Industries and controlled vapor technology. It's no secret Winston invented C-Vap, and for over 50 years we've dominated controlled vapor cooking and holding. Although C-Vap technology was originally designed for holding, it's available in a number of configurations for cooking and retherming. C-Vap covers all the bases of cooking, and it's likely there is a model and desired setting that will perform what you need it to do. Remember, since they don't require hood space, mobility, flexibility, and versatilities of the units are practically limitless. Winston C-Vap units are most commonly utilized in the school, healthcare, and chain segments. C-Vap can also be found worldwide and used by some of the most widely known chefs and restaurants to provide that extra hand in the kitchen. C-Vap is even used in stadiums for concessions, grab-and-go feeding sites, and even food trucks. If the power is there, you can utilize C-Vap. So we've discussed C-Vap technology, what it is, and how it benefits our customers. Now let's look at the different ways we package it into our equipment. As Barry said earlier, C-Vap was originally created for holding cabinets and specifically for holding fried chicken. That creation has evolved into a variety of different configurations through the years, from full-size cabinets holding 14 sheet pans to drawers holding single hotel pans. Our holding cabinets are available in 15 and 20 amp and come in 3, 5, and 7 series. Let's take a look at those now. 3 series C-Vap offers simple dual control of both water and air heat. It also features a convection fan for even heat distribution and recovery. 3 series comes in the same power as the 5 and the 7, but with simple controls, so it's all thrills, no frills. In addition to the features and power of the 3 series, the 5 comes with a touchscreen control, which has 8 preset programmable channels. The 5 series also features a USB port, which allows for channel programming, firmware updates, and download of up to 365 days of cabinet HACCP data. The 7 series is the next step up from the 5 and comes with the addition of a food probe, the ability to turn the convection fan on and off, and allows for programming the 8 channels via an Android app. Our smallest appliances featuring C-Vap technology are our drawer units. These come in single and double drawers and are available with or without a fan. They come in narrow or wide models and hold up to a 6-inch hotel pan. Moving from holding cabinets to cook and holds, our next level of C-Vap technology is the CHV series. Boxes and controllers look exactly the same as the holding cabinets, except now we have a 350 max temp oven that is hoodless and has unparalleled versatility. CHVs are available in the same 5 and 7 series as the holding cabinets and come in full-size units which hold up to 14 sheet pans and half-size units which hold 4 to 5 sheet pans. Our next version of C-Vap is our most powerful. The RTV, or retherm oven, has all the capabilities of the CHV, but with much more muscle. It's still 350 max temp, but with an extra air element and about 3,000 more watts of power. This allows for bulk reheating of frozen food and much better browning. And it's still hoodless. From sous vide to K-12 mass production, the RTV can do it all. It's like the gap between a convection oven and a combi. The RTV is available in the same 5 and 7 series versions as the CHV and the HOV and comes in the same size configurations. This concludes the Winston Precision Temp cooking discussion for FCSI. Thank you for your time. Please connect with us on our social media platforms to stay up to date on all things C-Vap. To receive CEU credits for today's class, please complete the questionnaire provided to you with a link to this learning session and submit to FCSI.